No one saw this coming. Not Elon Musk, not Wall Street, not the trillion-dollar electric vehicle industry. But somewhere deep inside Toyota's secretive R&D labs, it just happened. Something that wasn't supposed to leak, something that could wipe out the very foundation of EV dominance overnight. No press conference, no flashy reveal, just a quiet demonstration behind closed doors in Japan. A single prototype, no battery, no gasoline, no hydrogen tank, just water. And, within 48 hours, the shockwave had already begun. $17 billion in EV stock value, gone. Tesla staggered, Rivian plunged, Panasonic went red, because what Toyota's CEO allegedly unveiled isn't just a new engine, it's a direct threat to everything the electric revolution was built on. Rainwater, tap water, even seawater. The car doesn't store hydrogen, it makes it on the fly as it drives. No rare earths, no superchargers, no lithium, just a steady chemical reaction that rewrites every rule. Sources inside the room described the moment as surreal. One executive stood in stunned silence, another broke decades of protocol and applauded for 6 minutes straight. And for Japan's famously stoic boardrooms, that's not excitement, that's a seismic event. Because if this tech is real, and early leaks say it is, then the future doesn't belong to batteries, it belongs to water. So before this gets buried, before the lobbyists scramble to shut it down, hit that like button, subscribe, and stay with us, because what you're about to hear may be the beginning of the end for electric cars. Forget everything you thought you knew about hydrogen. This isn't the Mirai 2.0. That car used fuel cells, a separate tank, and complex pressurization. It was clean, yes, but expensive and limited by infrastructure. This new engine isn't that. This is combustion. Toyota has figured out how to burn hydrogen directly inside an internal combustion engine using a modified chamber that can handle temperatures above 2,000 degrees Celsius. The result: a roaring high-performance engine that produces only one byproduct: steam. But here's the truly radical part: the engine doesn't store hydrogen, it makes it. Using a proprietary nanocatalyst and a piezoelectric separation system, the vehicle extracts hydrogen atoms from water molecules in real time. That's right, while driving. You pour in water, and the car splits the H2O on demand, burns the hydrogen, and exhausts nothing but mist. How much water does it use? Around 5 liters per 100 kilometers. No battery fires, no grid overload, no rare earth metals, just water. And yes, Toyota says that includes salt water. There's no need for ultra-pure lab fluid. You could theoretically refill from a rain barrel or a river. So, why haven't we heard about this until now? Well, it's because this engine isn't exactly new. In fact, Toyota actually started building it 17 years ago under a top-secret program called Project H2X. The idea was sparked back in 2008, right as the world's focus was shifting to lithium-ion batteries. See, Toyota was already leading the way with hybrids like the Prius, but they noticed something others missed: the coming limitations of battery technology. So, they began working quietly on a combustion alternative, one that didn't rely on mining, charging, or those complicated cobalt supply chains. By 2012, Project H2X had working prototypes, but then it just kind of disappeared. No press release, no funeral, no leaks, just total silence. Insiders say it wasn't technical failure that killed it. It was pressure from oil companies, lithium lobbyists, and even Toyota's own hybrid partners. EV startups were gaining momentum, and honestly, a water engine would have threatened too many existing interests. So, Toyota shelved it. The engineers were reassigned, many to the more politically palatable Mirai project. Hydrogen fuel cells were seen as safer, more manageable, easier to regulate, and, well, easier to control. But you know, the world changed. By 2024, headlines were filled with EV battery fires, power grids were buckling under charging demand, lithium mining scandals were erupting across Africa and South America. And suddenly, Toyota's board saw something they hadn't seen in over a decade: an opportunity. Project H2X was revived in early 2025, and this time, they weren't starting from scratch. They dug up the prototypes, 3 vehicles that had been locked away in a temperature-controlled vault in Aiga Prefecture. Updated with modern components, the new test bed hit the road within 5 months, and what it delivered, honestly, shocked even the engineers who built it. But the world changed. By 2024, headlines were filled with EV battery fires, power grids buckled under charging demand, lithium mining scandals erupted across Africa and South America, and suddenly, Toyota's board saw something they hadn't seen in a decade. An opportunity. Project H2X was revived in early 2025, and this time they weren't starting from scratch. They dug up the prototypes, 3 vehicles locked away in a temperature-controlled vault in Iga Prefecture. Updated with modern components, the new test bed hit the road within 5 months, and what it delivered shocked even the engineers who built it. The vehicle accelerates from 0 to 60 in 4.3 seconds, faster than a Prius Prime and on par with many EVs. Its top speed is 180 kilometers per hour with no torque drop on uphill climbs. Range, a jaw-dropping 760 kilometers on a single 50-liter water fill. And the refueling process? No $2 million hydrogen station, no electric charger, just a garden hose. You connect it to the onboard port, flip a switch, and in less than 3 minutes, the tank is full. Unlike EVs, you don't need to wait hours for a recharge. There's no range anxiety, no battery degradation over time. Even more shocking, maintenance is simpler than on a gasoline engine. Toyota's engineers claim wear and tear rates are 42% lower than comparable combustion engines. Why? Because water vapor is the only exhaust, no carbon buildup, no soot, and significantly less heat stress on internal components. What started as a buried science project from the 2000s may now be the biggest existential threat the EV industry has ever faced. And what happens next could send shockwaves through every car maker, miner, and battery startup on Earth. Because the moment this hits mass production, everything changes. As of this moment, Toyota has already begun internal testing on multiple production-ready variants. No one was ready for the tremor Toyota sent through the electric vehicle world, not even Tesla, because if what's in this engine is real, then the entire EV supply chain, the lifeline of an industry worth over $1 trillion, just got hit by a silent, invisible tsunami. Inside Tesla's Giga Nevada, panic quietly set in. Battery modules once seen as the core of sustainable transportation were suddenly obsolete. Lithium, no longer needed. Cobalt and nickel, irrelevant. That $4 billion Panasonic battery plant in Kansas. A ticking time bomb of stranded capital. Executives from Lucid, Rivian, and even legacy titans like GM were reportedly summoned into closed-door meetings less than 24 hours after the prototype leak. The whispers were the same in every boardroom. If this water engine is real, we're done. It wasn't just the materials, it was the infrastructure. Thousands of charging stations across the United States, the entire supercharger network, rendered unnecessary. Recycling startups that bet their futures on dead lithium cells were already slashing staff. They saw the writing on the wall. You don't recycle what you don't use. And just as the industry began to comprehend the technological quake, the numbers started trickling in. This wasn't some sci-fi prototype requiring rare earth elements and platinum-lined fuel cells. The total engine cost, $1,320. Less than 1/3 the cost of a standard EV drivetrain. No onboard battery banks, no high-voltage inverters, just a small water tank, a hydrogen separator, a piezoelectric converter, and a supercapacitor the size of a lunchbox. The operating cost, a staggering 0.8 cents per mile. That's not a typo. Compare that to the 3.2 cents per mile for most EVs, already far cheaper than gas, and the economics just went nuclear. Even factoring in full vehicle production and energy sourcing, the lifetime emissions of this water-powered car came in 78% lower than the greenest Tesla, including manufacturing. And then came the kicker. Break-even point 1.4 years. That's how fast an average user would recover the entire premium through fuel savings. After that, it's nearly free transportation indefinitely. So, what kind of magic was buried inside this thing? At its core is something engineers once called impossible, a piezoelectric ultrasonicator. Using high-frequency mechanical vibrations, it splits water molecules instantly into hydrogen and oxygen on demand. Not stored, not compressed, not explosive. The hydrogen feeds a small combustion chamber while oxygen is expelled or reabsorbed. The energy is buffered not by a lithium-ion pack but by a dense supercapacitor array that stabilizes current and recharges from the car's own kinetic motion. Cold start verified at -22°C, meaning it works in winter. Emissions lab verified, trace oxygen and water droplets. That's it. No NOx, no CO2, no smog. The tailpipe steam on a cold morning is the only clue that anything is even running. And perhaps most critically, there's no hydrogen tank, no compression, no fire risk. The engine generates